Hi viewers, today we gonna to discuss about typical modeling a typical single line diagram in PowerWorld with all the available data, available input data and information. So let's assume this is one of the single line diagram power system model we want to build in PowerWorld and analyze. So here is a single line diagram, buses from 1 to 18, and then connected generation facility, transformers, transmission line, and load with each of these buses and shunt capacitors. So these are the 18 bus typical 18 bus system. We will model it in PowerWord with the available data from these tables like transformer setting, tab settings, what are the capacitor, static capacitor, and how we can put the base MVA. So, and then these tables data, this is like swing bus, voltage control bus and load buses. We have to define their voltage levels per unit voltage is angle, available power generation and active and reactive power generation. And then we can define the load connected, what is the load megawatts and megahours, active and reactive power, and then maximum and minimum generation at that particular voltage control bus. And then we can define the transmission line data and transformer input impedance like per unit resistance, reactance, and line charging. And then the ratings of the capacity of the transformer or transmission line. So here how these are connected from bus 1 to 2, from 2 to 5, and so on. So this is the connection of the buses. Now let's jump into PowerWord and how we can model this. So let me open PowerWord. So this is the PowerWord. I would like to open a new case. So here I am creating a new single line diagram. So actually this is a drag and drop simulation tool. So we have go back to see the connection. Let's say I want to draw the first line, first bus. So here is bus 1. So I will draw this bus 1, and as we can see here that this bus is a swing bus. Bus number 1 is a swing bus. So I will mention it as a swing bus. Here we can go into draw, and then under the network you have to click here, and here is the option of bus. I have to drag it over here and then click here where I want to put it. So yeah, this is the bus number 1. What is the name of the bus? I can mention it as a swing bus. So I have changed. And what is the rating? So the rating of this bus is 132 kV 1.06 per unit. So I have to mention this at 138, it's 132 kV. And how I want, what is the orientation, and here I have to put the 1.06. So 1.06 and 0 angle. So it should be matlab mean that toward the right, shape rectangular. So and what is the size? It should be the size and width. And then I can I can define the latitude and longitude also here. If there is a power system model, we are like at any particular latitude and longitude this particular bus is installed. So I can mention here the geographical location or open it via Google Maps. So these are the particulars of the bus. So and here we can define the zone, like I can name it, it's any zone from 1 and onward, and name of the zone I can mention it like a generation station, and balancing authority who is responsible for this. And here is the zone, area, zone, and all this thing, what is the name of this substation if I want to mention for my information, and then click OK. So this is the horizontally, I can move it anywhere, and I want to put it here. Now I go back and see what is connected with this bus 1. So with the bus 1, here is the generator. We have to attach the generator, and what is the generator data? Let's have a look. So with the swing bus, there is so we don't need to specify the generation data. So we have to drag and drop the generator from this. Here you can see the generator, and click here on the bus. The window will pop up that what is the megawatt specification. So we don't need to specify any power and voltage control. And here is the size. So it is up. I can put it over the bus, and here are the other. It is connected to bus number 1, yeah, to the swing bus, and is connection generator MVA base is 100 MVA. What is the fuel type? We can describe it over here, and let's say I can select that it's a coal type, and then in coal it's again unit type is I can select turbine geothermal, not this one. So I selected it like this, and then we can go to fault parameters. Here we can mention the internal sequence impedance, positive, negative, and zero sequence. Here we can mention the area and all those things. So save it and OK. So here is the bus size. I can reduce it like this, and I can move it. So this is the swing bus connected. Next we have bus number 2, and the bus number 2 has also one generator and a load. So I have to connect generator and a load to bus number 2. Again I can drag and drop from here bus, and here it is. I have to click and specify the bus 2 specification. It is voltage control, again 132 kV, 1.04. The generation is 40 megawatt, and the load specification is 21 megawatt and 12.7 megawatt. So I have to mention it here, the maximum generation and minimum generation also. So I will go and again 132 kV. In short, voltage controlled I can write as VC, voltage controlled, and then the bus information is 1.04 per unit. And okay, so again it's towards right, not vertical, up or down, and click OK. So this is the voltage control bus number 2, and I have to name it bus 2, bus 1 or swing bus. Okay, and then I have to connect a load and a generator. Here you can see that load option. I have to click it over this bus, and I have to specify with the provided data at bus number 2. So at this bus the 21.7 and 12.7 is the connected load. 21.7 megawatt and megawatt is 12.7. So uh, again, so it's not, what is the orientation of the load? It's towards downside, and I can reduce the size here. Okay, PF optimal 0, and then these are the information I have to save it. And okay, so this is the load. When I will simulate the connected load, and its rating will be shown here. So this is the load connected, and to make it short I would like to connect the two buses, that how they are connected from bus 1 to bus 2. These are two parallel lines. From bus 1 to bus 2, these are two parallel lines. And how these two parallel lines are connected? From 1 to 2, there is per unit resistance of 0.019, and per unit reactance is 0.059, and line charging 0.0264, and 150 MVA is the rating. So again, the bus 1 and 2 is connected as a transmission line. So these two are transmission lines, because the symbol of transformer is clearly indicated in single line diagram. So I have to draw a transmission line between bus 1 and bus 2. Let's say I make it close to this, and then here is the option of transmission line. I have to click on this here, and then double click here. Here the window pops up the specification of the transmission line. To calculate impedance, here I can put the length of the transmission line. Uh, so what is the unit? What is the unit of, like, it's electrical or per unit per MVA? So here is the power base is 100 MVA, and I can mention over here, let's say the default value is 10 miles per unit impedance and MVA limits. So I can put it here I can put here the data. Let's say I can put it from per unit resistance is 0.0198. I can copy it, put it here, and then reactance. So here is the per unit reactance, and then the line charging B. This is the line charging, and limit you can set just a single, because it's a single line diagram, so you can set for just a single value A, or you can set for the three phases like A, B, C. I can set it. So in this, if I want to change the unit into kilometers, I can change it to kilometers also. So it will be converted into kilometers. So in this particular case, the length is not defined, but you can define it. And here you can see that the per unit impedance also gets changed. So again, I have to put this MVA ratings, and this is the MVA rating I have to put it. So again, put it over here, and you can see that when I put the MVA rating, the capacity in terms of current ampere, it is shown here that 656 ampere current can flow through this transmission line. Then click OK, and then save it. Finally, OK. So a transmission line is made here. Again, if I want another transmission line, I can also copy this. Yeah, copy object and record, and then click here. So again, this is connected with the similar values I have put it over here. So this is the data, and in similar way I can draw this single line diagram with each and every details, and finally I prepared this simulation file with those 18 buses. So you can verify the load flow and the connection of any bus, load connected, capacitor bank connected to that particular bus, and all this connection by clicking on any particular bus. So let's say I want to check. So this is the swing bus. This is swing bus number 1, and its flow. You can verify it over here. This is the slack generator, what it generates 277. So here is the load flow, complete load flow. You can see here, and so this is the load flow. And then I want to go to case information and case summary. Here I can see that the load connected is 298 megawatt and 97 megawatt, and the generation is 317 megawatt and 171 megawatt. The total losses in the system is 19 megawatt. That's somehow large, and 86 megawatt. So this is the summary and modeling of a single line diagram in PowerWorld with accurate data. Any question or any concern about PowerWorld simulation, modeling a single line diagram in PowerWorld? Uh, The PowerWorld allows us to model a power system up to thousands of buses. So it's just an example, and you can make your own single line diagram in PowerWorld. Thank you. See you in next video.